Homework 3.3, Polynomial Division, Factor Theorem, and Remainder Theorem, video 5. Homework due Wednesday, May 27th at 11:59 p.m. The following example will correlate to homework questions 9 and 10. By the way, 6, 7, 8, 9, and 10 are all just synthetic division problems, but 9 and 10 have an issue. For example, consider this division problem. Divide x to the fifth plus 4x to the third minus 5 times x plus, by x plus 1. Not times x plus 1, divided by x plus 1. Well, we could do long division, but we could do synthetic division because the divisor is of the right form. This one is x plus a number. But do you see why this synthetic division problem has issues? Hint, it's in the numerator, aka the dividend. There are some missing powers. The degree of the numerator is 5, and in a fifth degree polynomial, I expect the next term to be x to the fourth, and then x to the third, then x to the second, then x to the first, then no x's, also known as the constant. What am I missing? Well, there's no x to the fourth, there is an x to the third, there's no x squared, and there's no x term. So the numerator is missing x to the fourth, x to the second, and x. So if we were doing a long division problem, we would have to write x to the fifth plus 0x to the fourth, plus 4x to the third, plus 0x squared, plus 0x minus 5. Just like in long division, in synthetic division, missing terms need to be represented with the 0 coefficient. The danger in synthetic division is if you forget to represent missing powers with zeros, you will be able to perform the synthetic division because there's no check for misaligned terms because you took the x's out. So you'll get an answer and it'll be totally wrong. So even more so with synthetic division than long division, if there are missing terms, you've got to catch them and represent them with zeros. So how would this one look when we set it up? First off, what number goes in the box? The box number is the opposite of the number in the divisor, of the constant in the divisor. The constant in the divisor is positive 1, so the box number will be negative 1. And by the way, and you are always welcome to do this, feel free to pause the video and try the problem before I go through it. I just hope you set it up correctly. All right, so let's set it up. Now you don't have to switch colors, but I'm going to use a red marker every time there's a missing term and represent it with a 0. The top row is the coefficients of the dividend. So starting with x to the fifth power, its coefficient is 1. There is no x to the fourth power, so its coefficient is 0. The coefficient of x to the third power is positive 4. There is no x to the second power. There is no x to the first power. And the constant term is negative 5. Again, it's even more critical in synthetic division to catch missing terms because if those zeros weren't there, we could still do the work and everything would seem okay. All right, so if you're comfortable with the setup, now let's just do the work. And remember, the work is just left to right. Starting in the first column. You add and then multiply diagonally by the box number. So I'll call out every move as I do it. Then I may do it again, showing you how fast it should go. All right, if we add up the first column, the only number in it is 1. So for the first column only, you bring down the first number. Then you multiply by what's in the box. 1 times negative 1 is negative 1. That takes you up a row and over to the next column. And then add. 0 and negative 1 is negative 1. Then multiply diagonally by the box number. Negative 1 times negative 1 is 1. Add. 4 plus 1 is 5. Multiply diagonally by the box number. 5 times negative 1 is negative 5. Add. 0 and negative 5 is negative 5. Multiply diagonally by the box number. Negative 5 times negative 1 is positive 5. Add. 0 plus 5 is 5. multiply diagonally by the box number. 5 times -1 is -5. And then add up the last column, -5 and -5 is -10. Add, multiply, add, multiply, add, multiply, until you get to the last column and add it up. So what's our answer? Remember, the bottom row represents the coefficients of the quotient, but you lower the degree by 1. We started with a 5th degree polynomial, which means our quotient will be a 4th degree polynomial. This one represents the coefficient of x to the 4th. So 1x to the 4th minus 1x to the 3rd plus, because it's positive, 5x to the 2nd minus 5x to the 1st plus 5. You should run out of x's right before the last number, because the last number is your remainder. So -10 goes on top of the divisor, which was x plus 1, and gets added onto the quotient. So that's it. Again, I really can't stress how easy and kind of important synthetic division is going to be. Just a foreshadow as I set up this problem again. In the next section, we'll be doing a lot of trial and error using synthetic division as our tool for checking something. So it'll be important that you can not only do it, but do it efficiently. So I just set up the synthetic division problem again. I want to show you how quickly this should go, even if you call out your moves. In practice, I don't, I just do them. Add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Of course, the speed depends upon the size of the numbers that you're adding and multiplying. Sometimes the numbers start growing really large and you have to slow down and get out a calculator. Oh, by the way, if we wanted to check this, what would we have to do? If we wanted to check this, you multiply what you divided by, x plus 1, times your quotient, which was x to the 4th minus x to the 3rd, plus 5x squared minus 5x plus 5, and then add your remainder. Now you don't have to check it, but just to make sure that I'm not blowing smoke here, I'm going to multiply. This distributive property is going to be really easy. We just have to distribute the x, which means everybody picks up one more x, and distribute the 1, which changes nothing. So let me write everybody with an extra x, x to the 5th minus x to the 4th, plus 5x to the 3rd, minus 5x to the 2nd, plus 5x. So that's me distributing the x to everybody. And now distribute a positive 1, which doesn't change anyone. So I just have to write these. Plus x to the 4th, minus x to the 3rd, plus 5x squared, minus 5x, plus 5, and we have plus -10. Let's gather like terms. The only x to the 5th is here. So we're done with him. There's only 2x to the 4th terms, but they cancel, which is good because we were missing x to the 4th. Here's an x to the 3rd, 5x to the 3rd. Here's another one, minus x to the 3rd. So those combine to give positive 4x to the 3rd. Correct. Now I'm expecting more canceling. Negative 5x squared and positive 5x squared cancel. Positive 5x and negative 5x cancel. And then positive 5 and negative 10 is -5. And we got the original dividend back. Hooray! By the way, the whole checking thing is something that we're about